Oh,
Good evening, all. I, Dr. Prabir Kumar Shetty, the convener of this FDP, welcome you all to the second day of third session. That means 2 days it is third session, but in the FDP it is the third session. In this session, our research person is Dr. Sikha OK from University of Pompeu Fabra, Barcelona. So I like to introduce her. Sikha received her BTech degree in Information Technology from Calicut University, Institute of Engineering and Technology, Calicut, and MTech degree in Computational Engineering and Networking from Amrita School of Engineering, Coimbatore. Presently, she holds the position of a senior researcher at the Barcelona MedTech Research Group, University of Pompeu Fabra in Barcelona, Spain. Previously, she worked as a visiting researcher at the Center of Biomedical Engineering Research Group, Polytechnic University, Catalonia, Barcelona, Spain. Before taking on her current role, she worked as an assistant professor in the Department of Computer Science at Amrita School of Computing, Amrita Vishwavidyapit University, India. Her primary research interests include explainable AI, uncertainty in deep learning models, and computer vision applications in agriculture and healthcare. She has authored numerous publications in Tier 1 journal and conferences. So, I welcome you, madam, in this session. So, I hope all of our participants, that means all these faculties of the different states and different institutes of our country, India, will enjoy your session. Now the session is
Thank you.
yours.
Thank you. I'll share my screen.
Yes, ma'am. You can share. Yes, it's visible.
Uh, so hope it is visible in the presentation mode. Okay, so thank you for the kind introduction. So myself, Shika, I'm currently working as a senior researcher at the Barcelona Center for New Medical Technologies. So my research group is an interdisciplinary research group, so in which includes both the biomechanical domain as well as AI and computer vision domain researchers. So my position in this research group is mostly towards computer-aided surgery and provide AI solutions for that. And I work closely with doctors from Europe, where we are working on abdominal cancer evolution and building most trustable AI solutions for computer-aided surgery. So thank you again for inviting me for this talk today. So the title of my talk is From Black Box to Glass Box, Building Trust in AI with Explainability and Uncertainty. So I would like to have a discussion on these two aspects of you know AI research, that's explainable AI and uncertainty quantification in AI solutions, mostly towards computer vision based applications and medical imaging. This is a brief
ఎవరు చెప్పారు
abstract
వస్తే వచ్చినాయేమో బిర్యానీ పెడదాం రెడీగా పెట్టుకోండి అంత
brief abstract of today's
కావాలంటే
talk.
పెట్టుకో
So I'll be I'm going. I mean, I'll be talking
పాత
about
ఫోన్
AI powered solutions. Sorry if you all can mute your audio, would be really great. Thank you. AI powered solutions and its pros and cons. And I'll start with the basic definitions of explainable AI. So, what is explainable AI? Why is it important? And how we can achieve so-called explaining this AI models or make AI models more transparent for critical applications like national security or healthcare. There, I would like to have a discussion on the current state of the art in this domain and what kind of research that we are doing in our lab in this direction, particularly on post hoc and anti hoc explainable AI methods for computer vision, and a brief introduction to uncertainty. So, in fact, explainable AI and uncertainty go hand in hand. One talks about the confidence of the model, where the other one talks about how uncertain or certain the model is in its predictions. So I assume that you all might have had a detailed overview of deep learning for computer vision in general, or medical imaging in particular. So I'm going to talk in that, from that perspective. So as we all know, from the very basic applications like, say, starting with image classification to the very complex computer vision based problems like visual question answering or generating image descriptions, prognosis, diagnosis, whatnot. Everywhere we have seen these kind of papers and research, abstracts that comes and says like AI can perform better than a human expert. So the real question comes, should we really trust these models? So as we all know, if any AI-based solution is a deep learning model that tries to understand or try to derive a complex mathematical function between the input and the output. So it purely depends on what the data that we are going to put into the model to train the network and to make the prediction. So this question has become really relevant maybe after this first incident when the Google self-driving car caused its first crash back in 2016. So Google self-driving car is one of the pioneer or one of the most, where all the different types of computer vision or AI solutions comes in picture. So when this incident happened, when people tried to decode the reason behind this incident, at the ground level, the reason was an AI model, AI models failed to differentiate between two very similar classes. So that was the very basic reason behind the first crash of Google self-driving car. So from this moment onwards, I think people started questioning the trustworthiness of any AI model, whether they are really reliable or whether we can rely on the numbers. And I don't remember the exact year, but this was another major incident where an MIT researcher, Joy Volankini, come up with some findings of her own regarding the face recognition system. So as we all know, face recognition systems comes in a category where AI can perform better than a human being. But she found that the face recognition system deployed in her institution itself is failing to differentiate or failing to recognize Black women. So that was the first point where she started a legal league against the AI solutions, because the AI solutions are highly biased towards the gender and the races. So we had so many other examples like this, where we came to know that we cannot trust these models just based on their numbers, because so far, to evaluate all of these kind of AI solutions, what we have is some kind of numerical evaluation metrics. Say, for example, if the task is a classification, we used to say the model is, say, 99.9% accurate or precision, or we have other metrics like precision and recall. But all of these are just like numbers. So it came to a point where researchers understood that we cannot trust any of these AI models in terms of any of these numbers. So that actually motivated towards this particular line of research, which is known as explainable AI, So the reason is, so far, whatever we have to evaluate this AI model is just based on a number. But as a human, we need more reasoning behind the prediction. So if we are saying a particular aspect of, say, any particular scenario, we normally come up with some human understandable concepts or human understandable reasoning behind our decision or a prediction. So that is the major aspect of this particular research line, explainable AI. So let's see what is mean by explainable AI, or it has many other, synonyms as well. People used to call it as explainable AI or interpretable AI. But what exactly it is, to be honest, there is no consensus yet because it's still in its infant. It's kind of a very latest research domain, so it purely depends on who is asking for explanation. Say, for example, as a model creator like us, if we are asking for explanation, we will be more interested to understand, or we would like to explain the inner working of the model. So what is the reason behind this particular decision? So when I plug in this particular data, what are all the neurons or neurons who are responsible for this particular decision? So for model creators, for us, the explanation is mostly kind of neuron level understanding on what the model is doing, and we can use these kind of understanding to improvise the model. But then, if the person is a model examiner or a regulatory body, for them, the explanation is mostly on how the input and output variables are related to each other. So it's kind of local feature attribution. So I can say, so if I change this part of the input, how the model prediction is going to change. So for them, it is mostly try to understand the bias in the model in terms of the model itself or in terms of the data it is being used. So for a model examiner or a regulatory body, the explanation is mostly towards the correlation between the input and the output. The next question is why it is so important. The first thing is Google Trends. So this graph is from a recent Google search on this particular term called explainable AI. So the exponential growth itself shows that people who are all doing, especially academic research or industrial research in terms of AI, they want to include some aspect of explainability or interpretability of their model in their publications or the products, primarily because of the regulatory bodies. So in European Union, there are strict rules of GDPR in terms of sharing data, particularly medical data, and also in India also, I think there are a lot of rules and regulations that comes to and tries to regulate the AI solutions and the deployment of AI solutions, particularly for very critical domains like national security, as I mentioned earlier, or the healthcare domain. So another reason is this kind of explainability will bring some kind of transparency to the model. It's not just a prediction and the accuracy in terms of some numbers. It also provides some reasoning of why the prediction is like that or why not this is like that. So when we have a misclassification, if we can explain the prediction or the reasoning behind the model's prediction, we can understand where and why and how the model went wrong, which will also facilitate a better model validation and debugging. So I have an example here. So in this particular example, so assume that there is a classifier and the classifier classifies husky, which is being misclassified as wolf. So earlier, what we used to do is to print a confusion matrix that say this many instances of husky is being misclassified as wolf. That's it. But we never knew what was the reason why the model was not able to do the classification correctly. So here comes the explanation map for the same task. So when you see the explanation map, now we know that the model misclassified a husky as a wolf because the model was not looking at the region of interest, that is the face of the object, Rather, it was looking towards the background. So when we know this is the reason behind it, what we can do, we can retrain the model, adding more instances from the same class of different background, and make sure that we get enough variance of data within the class for the model so that the model can perform better and it can reduce misclassification over the time. Another reason could be we can use this kind of explanation to understand the weakness of the model, especially bias in terms of data. Say, for example, I have given two different examples. In the first row, we can see that even though the model make the right decision, so the input image is of a nurse and the prediction is a nurse, but then in this case, the model is looking towards some generic aspects, say some features from the background, but not very specific. So there the model could be a biased model, but in the unbiased example, when you see to understand a nurse or a doctor, it is looking at the stethoscope. So for a human, for a nurse or a doctor, stethoscope is a very generic concept that we use to understand who the person is. So these kind of explanations primarily will help us to understand the model and also to improvise the model by debugging the fault within the model or within the data. So the next question. So now we answered what is meant by explainable AI and why it is very important. Now the third question, which is very important, that how to explain a model. So for that, maybe I should start with something called intrinsically interpretable models. So intrinsically interpretable models are very simple machine learning or classical machine learning or deep learning based models. An example is a decision tree. So the reason behind the prediction of the model is interpretable just by looking at the model's parameter or the model summary. Say, for example, in this case of decision tree, it's very easy for us to understand the reason behind any decision. Say, for example, the reason behind this decision, we can just traverse through the branches starting from the root to the leaf node. It's very easy for us to say we can easily generate a conditional structure. So age less than 25, and if it is a student, then the decision is yes. So it's very easy for us to understand or derive some kind of human understandable concepts from these kind of models. And in this case, say it's a linear regression. So we can say that age is very important. And then the most important parameter is income. So these are all the intrinsically interpretable models, which are very simple mathematical functions, try to map input and output. And then from their structure itself, it's very easy for a layman person itself to, or himself or herself, to understand the reason behind their prediction. But the problem is that, so these kind of very intrinsically interpretable and simple models, we can use them to solve small tasks, very easy tasks. But if we want to solve complex computer vision tasks, as we discussed before, we cannot rely on these kind of intrinsically interpretable simple models. Obviously, we have to move towards complex models. So I have a graph here. So when you move from the left to the right, so these models in the left region, they are very interpretable and very easy to implement, easy to understand, but they are not suitable for complex computer vision tasks. And as we move from left to the right, the model becomes very complex. They become very less interpretable or explainable, but they can solve complex, computer vision problems. Say, for example, decision trees, you can just traverse through from the root to the node, and then you can understand the relations or the reason behind the prediction. So if it is a linear regression, you can change the decision boundary patterns, and then you can understand if I change this parameter, how it is going to be, how the regressor are going to behave. And I think the moment when we switch from decision trees to random forest, a kind of black box model, black box nature is getting inherited from this model. So for example, when it comes to a random forest, and if you want to understand the decision why random forest gave this particular prediction, we may have to decode multiple decision trees, and then we may have to come to a common ground. Okay, because of all these reasons, this prediction has been made. So from random forest onwards, I feel the black box nature starts. So as we move from random forest to neural network, so this is a very simple multi-layer perceptron, which is highly densely connected between the layers. Because of the number of parameters, it is very less interpretable. And when we move from one dimensional to 2D or 3D, where we primarily use a very specific network architecture called convolutional neural network. So there, the number of parameters may be millions or billions, make it even more less interpretable. So the question is how to explain these kind of architectures. So now our focus is mostly towards architectures that comes to this part of the talk, that is convolutional neural network. So how to explain these kind of complex computer vision based models, say convolutional neural network, autoencoders, etc. So in the literature, based on the literature, the explainable AI methods that are available out there can be broadly classified into two different classes. One is post hoc explainable methods. The second one is anti hoc explainable methods. So post hoc explainable methods, the idea is the model is already trained. So these methods try to analyze and interpret the reason behind the model's prediction after it has made prediction. So the model is trained and deployed. After that, we are trying to use some mathematical formulations or DL-based solutions that will come later to understand what is the reason behind it. And the mostly available solutions are in terms of heat maps. So heat maps just say, based on the heat, wherever you have, say, this red regions, that are the regions where the model has considered the most to make that particular decision. So that is post hoc explainable models or methods, wherein anti hoc explainable models or methods are the most optimized way of doing that. So whenever you design a model, within the model design itself, you should have a module to explain its own prediction. So it's something like you have a model which can do a particular task, say classification. Along with doing the task, say classifying images or videos or whatever data you have, along with the task in hand, generate the explanations also. So something like, say, decision tree. So these are the three different types of methods. Black box model, we don't know the explanation. So the conclusion is we cannot trust them. Post hoc methods, the model is already trained. We are trying to decode or understand the already trained models. Anti hoc explainable models, within the model development itself, whenever you develop a model, you introduce a module for explaining the model. So the model will be doing the task. Also, it will generate its own explanations. So let's see the existing literature in this. I'm just providing literature on post hoc methods, because when you see the explainable AI state of the art, more than 95 to 96% of the research out there is mostly based on this particular aspect, that is post hoc methods. So post hoc methods itself, so there are different ways of classifying them. So I just put the one that I felt it's more relevant. So there are many methods which are purely based on gradients. So it's based on how the gradients flow from input layer to the output layer and output to the back. So it starts with class activation maps, saliency maps. GradCam is one of the very famous one, and there are different versions of GradCam out there. So all of these kind of methods try to understand or generate heat maps, and based on the heat map, they try to explain the reason behind prediction. So these gradient-based methods, mostly they are applicable only for architectures like convolutional neural network, which means most of them are not model agnostic, they are model specific in nature. So the next category is model agnostic methods. So it's the two famous candidates in this category. They are Lime and Sharp. So these two kind of models can be applied irrespective of the model. So you can also use it if your data is text. You can also use it if your data is image, video, or whatever it is. And another category is deep learning based explainer. So there are a lot of research happening in this particular domain of post-hoc explainability, where people are coming up with a deep learning model which can explain another deep learning model. So in this kind of solution, what I have seen is an extra effort has to put to explain the explainer, because the explainer itself here is a deep learning model that try to explain other deep learning models. So we need some kind of interpretation or explanation of the explainer itself. We will have a discussion on this. And the fourth category is one of my favorite category. So that's empirical analysis or meta-analysis. So here the idea is, if we can use our high school math to decode and understand this complex architectures, deep learning architectures that say convolutional neural network, that is the best thing to do, right? So this kind of analysis, they are more theoretical in nature, but they use very simple concepts like, say, singular value decomposition or very simple matrix decomposition methods to understand and decode the reasoning behind the prediction of these complex models. So let's move towards my ongoing research in these categories. So let me first start with what we have done in the post-hoc explainable methods in general, and also we have some use cases for medical domain. So and then we will move towards few. I think one of my work on Andy Hock explanation models, and then science-induced deep learning solution. So this is a new area we just started our study on, where we are trying to distill a black box into interpretable expert. And for individual expert, if we can induce the actual physics, or say, for example, in the case of medical domain, if we can induce the experience and the knowledge of a doctor as a medical report, how it is going to be, and the data-driven methodology to understand the actual reasoning behind these models using very simple mathematical formulations and uncertainty in deep learning. So let me start with the first aspect of what our the very recent research, where we used it comes under empirical analysis that I explained earlier. So here we have used a concept called dynamic mode decomposition, which is a very simple matrix decomposition. I'll explain this in detail. But let me first explain what is the motivation behind this particular work. So as we are all working in academia, most of us, and industry, reproducibility of a research is something that we really want these days, isn't it? So we are very much used, or most of the time to start a research, maybe because of less resources that we have, we are forced to use pre-trained models that is being reported in any of the published research. But when we use these pre-trained models, we may or may not, mostly when it comes to medical domain, we may not have access to complete test or train data, or we don't know the very particular parameter details of the model, say loss function or any other parameters. But still, it's come to a point where we have to trust the authors and use the model and the weights, whatever they have given in their website, published in their website, or sometimes we may have to mail them and ask them. So whatever they are going to give us, we are going to use that to advance our research. So the question is how to trust them. In general, the traditional matrices to evaluate any model, say accuracy for classification, die score or IOU for segmentation task. So whatever be the task in hand, it demands for train and test data. But if we don't have access to train and test data, is there a way to assess them? Obviously, we cannot assess them in a very specific way, but at least is there a method to evaluate the quality of the model? I mean, whether they are properly trained, is it under-trained, is it overtrained, or whether what is the generalization aspect of that? So at least to deal with this aspect, the quality of those models, if we have simple tools, say some very simple mathematical tools to understand the evolution and effectiveness of these kind of models would be really nice. So that is the motivation behind this particular research. So dynamic mode decomposition, it is a matrix decomposition method, which is primarily being introduced in the fluid dynamics community to model any system without an equation. So it's a completely data-driven approach. So it's kind of mostly for fluid dynamics, the actual flow is you have a system of equations and then you model the system. But in that case, we may not be able to actually understand the other environmental, factors that may affect the system. So that is the motivation behind this particular theory. So here the idea is go back. So you have a data, that's the observation that comes from the system. Using those data, can you model the system back? So that is the basic theory behind this particular decomposition method. And the cost of DMD is the cost of singular value decomposition, because the dynamic mode decomposition built on top of singular value decomposition. So as per the theory, if you have to apply a dynamic mode decomposition, we need say observations from different times. So in our research, what we have done is, so this is a post hoc method. So the CNN is already trained for a particular task. So we evaluated this empirical analysis on 2 different tasks to show that this method is task agnostic. So if you have a CNN backbone, say whether it is a segmentation, classification, or any other task that you do, if you have a CNN backbone, you can use this analysis to at least understand where the model stands. Okay, so for that, the first objective was to give a linear representation. So we didn't consider in this research, we considered CNN as a linear dynamical system. We didn't consider the nonlinearity aspect because we need more mathematical formulations to deal with the nonlinearity aspect. And as we know, the CNNs, they learn, every filter learned from the previous filter. So the learning happens incrementally. So we extracted the feature map from individual filters and we consider them as they evolve from one filter to another filter. So the evolution is kind of what is the information or what is a pattern that is being learned by these filters one after another. So that's going to be the snapshot matrix here to apply DMD. So dynamic mode decomposition will decompose the snapshot matrix and then into DMD modes and eigenvectors. And from these eigenvalues, we have this DMD CNN analyzer. So this DMD CNN analyzer introduces few customized matrices like entropy of DMD mode, spectral gap, and DMD modes with 0 amplitude to understand the evolution or the learning reason behind these models. So the first observation what we found was, as we learned any CNN or any deep learning model over epochs, so the system, since it was being considered as a linear dynamical system, So the system starts from a very random distribution, and then it tries to converge over epochs. And then we introduced a few matrices. The detailed aspect of all of these study and analysis is available in our paper. So in our experiments, we found that this particular metric, that is entropy of DMD eigen spectrum, they had a correlation with the accuracy of the model. So what we found was the entropy of this DMD spectrum is, if the entropy is less, the model is more accurate. So the idea is very simple. As the model goes through the epoch, as the model becomes more generalizable or stable, the entropy, that is a measure of randomness, is getting reduced. So that's a very basic understanding of the whole concept. So we analyzed the application of EDMD, that's what the metric's called, in terms of classification and segmentation across generic image classification data sets and also medical data sets. And we tried whether we can use this particular metric to understand whether a model is poorly trained or well-trained model. Because if we don't have access to full train or test data, it is highly impossible to tell what exactly the test accuracy is. Okay, so instead, we can use these kind of, say, this particular metric to understand, or at least to try to differentiate between poorly trained model and well-trained model. We also tried, just by taking the stable DMD modes, to give an interpretation of the decision. So again, this interpretation, we have generated heat maps. So the heat maps, these are all the heat maps that have been generated by this simple method. So this heat maps will highlight the regions that is being considered by the model to make the decision. So the heat maps are highly localized, and they are highly, it is just looking at a very specific part of the image to make the decision. So moving towards the next category of interpreters, that is deep learning based explainer. So the previous one is the empirical based explainer. So where we used a very simple matrix decomposition method to explain the architectures. So in this research, we introduced a deep learning based explainer. So as I explained earlier, the explainer itself is a deep learning model. So we also have an explanation for the explainer. So here we used a conditional GAN to understand the reason behind CNN prediction. So this particular model also, they're task agnostic and model agnostic in nature. So wherever you have a CNN backbone, you can use this particular model. So the idea is conditional GAN work on generating, they'll generate images, but we can condition the GAN. So to condition the first part of this network, we used the cumulative GradCam averages. So cumulative GradCam averages are generated by the intermediate filters from the underlying convolutional neural network that we are trying to explain. And these CGMAs these CGMAs are used to condition the network. So we tried two different types of conditioning the GAN. One is the local conditioning. So as I shown here, local conditioning is after every convolutional block, we have a condition network, and every GradCam from the intermediate blocks are being conditioned and given to the GAN. And the second category is global conditioning. So we call it as GSFT GAN. So in this, all the CGMAs put together pass through the condition network only once, and then pass to the GAN for training. So when you see for the discriminator, the label is the actual GradCam. But in the experiments, what we found was, even though we use the actual GradCam to condition the GAN and to train it in a supervised manner, the explanations that is being generated by our model, so the last two columns, GSFT and LSFT, so the explanations were also have some, similarities from other explanation models as well. So, which means the model was able to capture, generate explanations where GradCam failed, but those kind of regions were very visible from other state-of-the-art methods. And this is few examples from image descriptions. So in that case, say for example, when it comes to image description models, you have two different aspects. So you have a computer vision pipeline and you have a natural language pipeline. So it's a kind of mixing NLP with computer vision. So we also tested the efficiency of this explainer in this realm, and we also have some quantitative measures. So the question, as I explained, the first question is, since it is a deep learning model that is trying to explain another deep learning model, so it's a kind of egg-chicken problem. So we have to explain the explainer. So for explaining the explainer, we used a concept, concept similar to LRP, where layer-wise relevant propagation, which is a very famous explainable explanation methods available in the literature. So we try to understand the contribution of individual CGMAs, because the main aspect of our research is CGMAs and how we condition the GAN. So we try to understand the importance of these individual CGMAs by blacking out the individual CGMAs while testing the model. And what we found was for a CNN to make decision, every layer matters, because most of the existing post-hoc methods like GradCams and the different variants of GradCams, they just use a final convolution block. But in this research, we found that all the layers starting from the beginning to the last, from the very first layer to the deepest layer, every layer, in fact, has an importance to understand the actual working of the model. If we just consider the final convolution block, there will be some kind of information loss that we can expect. So moving towards, so these two are post-hoc examples of the, the model is already trained and how can we decode. But the very optimal way of designing any AI-based solution is go anti-hoc. Like while you design a network itself, be it a classification task or a recommendation task, whatever be the task in hand. So while designing your network itself, if you can have a capsule or a module which can generate its own explanations on the go while training itself, is very much appreciated, because that will help us to generate more robust outputs. So this is our first work in this direction. So this is the underlying network to be explained. So for any underlying network, there will be a task specific loss. So the task could be, so there will be a task specific loss. So if your task is classification, you can have classification based losses. If your task is a segmentation based specific losses, say IOU or dice code, whatever it is. So for any task, there is a task specific loss. And then this is our interpretation module. We call this module as a weight network. So the idea is, whatever be the architecture that you have, whatever be the task that you're doing, you can plug in this module on top of it. It's a kind of an extra plugin. So take this module and plug in on top of your underlying network. So this capsule will generate explanations based on the task. Okay. So now let's see what is the weight network is. The weight network is a very simple autoencoder. So this autoencoder, the output to the autoencoder are the features that comes from these convolution blocks. So we didn't use any other explanation map. It is purely based on the features that is being generated by the underlying model. So we extract the features. So the number of features is eta, in our architecture, which is a hyperparameter, you can decide how many feature maps that you want to consider. But my genuine suggestion is to consider all the feature maps starting from the first layer to the last layer, okay, for a better explanation. So these feature maps are passing through this weight network. Now, what the weight network will learn? So this weight network will generate some weighted combination of these feature maps and come up with an interpretation map. So how the weights are being learned, I'll explain that. So this interpretation map is being multiplied. It's element-wise Hadamard multiplication with the input image, which is again fed into the same network. Okay, so this is the architecture, but let's see how the training works. So the training is a two-phase training. So it's a kind of train, pause, and then train again. Train, pause, and train again. Because the input for the explainer module, it should come as feature map from the underlying network. So the minimum number of iteration that the underlying network has to train is 1 to start this network or to initiate this network. So we train this network first and then extract the feature maps that will go into the weight network. So we have a output that comes after this Hadamard product, which will pass through the same network. So the idea is we are going to penalize. We have an interpretation loss here. So we are going to penalize this explanation module so that it will not or it should not generate the whole image as the explanation, because I'm not looking for the same image as the explanation. I'm looking for the particular position, the most important position that is being considered by the underlying network to make the prediction. Okay, so that is being calculated. This interpretation loss is being calculated based on the prediction of Y first, that is the task specific prediction. Y second is the prediction that comes from this input. Okay, where your interpretation map is being multiplied with the input and then go through that. So we are just penalizing the network, focus only on the important part, not the whole images. So the advantage of this particular architecture, what we proposed was, earlier in the literature, most of the explanation modules, they were producing some kind of heat maps. So heat maps requires another manual intervention, like an expert intervention. It's like a AI expert to explain, okay, why and what is being considered. But in this particular Andy Hock framework, we were able to generate concepts, not heat maps, so which does not require another human intervention to understand the reasoning behind it. Say, for example, for cat, for the particular class cat, the cat eyes are important, or what part of the, and we found that different concepts are being learned by the classifier to understand a particular class. So it's not like when it comes to cat, only the eyes. It is also considering, say, the other ear part of the eyes. So we also found that different concepts are being learned by the same classifier to understand the same class. So this was our first entry to the very famous CVPR conference in 2023. So moving on, so I've discussed one sample from Andy Hock, few samples from post-hoc methodology. Now let's see, apart from these kind of techniques, is there anything that we can do? So we have a lot of explanation methods that are available out there. Can we use these explanation methods to understand the trustworthiness? So the answer is yes. So next comes the question, do we need an entire image? Say, assume that you are a doctor. Do we need the whole image to predict the class? So this is mostly what a CT scan machine generates. But for a doctor to understand or to diagnose this, he may be interested only a particular part of the image, maybe this part of the image. So even though we have a big whole, high resolution image volume, CT or MRI volume available with us, for a doctor or for a domain expert, only a part of the whole image is important to make a decision. So the rest part of the image is going to behave as a noise for the model that we are going to build. So if we can just identify the region of interest and then use these region of interest to train the model, that is going to improvise the performance of the model, because we are not giving any noise signals as an input into the model. So that is the motivation behind this particular work. So it's a 3-tier architecture. So what we have done is we utilize the existing explanation methods that are available out there, and we build on top of that. So as I told, it's a 3-tier architecture. We tried initially this for skin cancer classification. So there is a global branch which act as the first, maybe I can call it as a teacher, and there is an attention module, which in where we use the GradCam or any explainable methods that are out there as a hard attention module, and then there is a local branch. So the idea is the global branch is trained for minimum number of epochs, just to make sure that it has already learned some patterns between the input and the output. And based on the global branch, we generated a few explanation maps. So this is kind of what is the knowledge being learned by the global teacher model. Okay, so that is being encoded here. And we use this encoded information to train our less complex local branch or a student branch, I can say. But for the student branch, we are not going to input the whole image. We are just going to distill the knowledge that is being learned by the global branch. So in a way, we are trying to reduce the noisy signals, that is any region which is not important for a model to do the task. We are going to remove them based on post-hoc interpretability modules as an attention module, and we are going to give them as an input into the local branch. So our observations showed that in terms of classical measures like accuracy, precision, recall, F1 and AUC score, we were getting very good performance across different architectures that are available in the literature. And we also noted that since we are avoiding the noisy part of the image, anything other than the region of interest is the noise, the networks were able to, converge very easily. Like with less number of epochs, it was able to converge. So this is where I want to show, like in this line of research, you can also think about things where you can use the existing research and build models, more trustworthy models on top of that. And few other research is this first one is the rule-based explanation of deep classification networks using regional feature. So in short, here we try to combine these two realms together. One is the machine learning community and the deep learning community. So we try to explain the convolution neural networks using very simple decision trees. I'm not going to explain this. All of these are available in my profile. So the most important question, all good, is there anything to worry about? So I think to explain this, I feel like this very famous book, The Inmates Are Running the Asylum from Alan Cooper, is really relevant here. So in this book, he talk about, even though we have good softwares, they're talking about why the user interfaces are so bad. So the same thing is happening with explainable AI line of research also, because definition, objectives, what, why, and how explainable AI work, everything is driven only by AI researchers, often without sufficient inputs from, say, domain experts, say doctors. Another one is there are no benchmark matrices available. There are few matrices available, which is purely based on the robustness of the model. But most of the matrices to evaluate the existing explainable AI methods are purely based on visual evaluation, that is highly subjective. Maybe just by looking at a heat map, I can say this part of the image is very important. Somebody else can say, no, the other part is so important. That is highly subjective. So we don't have a particular benchmark matrices to evaluate these XAI methods. And we also need, more methods that are Andy hoc in nature, and also they can generate some human understandable concepts. And I think this is very important, lack of domain specific workflow. Say, for example, for a doctor, he may be following some rule book to make, say, some diagnosis or a decision. So in this case, that particular workflow is very important. But fortunately, in this domain, a lot of research is being happening, called mechanistic interpretability. So they are trying to decompose the black box into a mixture of experts, and each expert is being trained only to follow a particular rule of, say, the actual workflow as a human expert, and over reliance on positive explanation. So all of these drawbacks actually says that this particular research domain has a lot to do. So a lot of research opportunities are available, and this line of research is very important because of AI regularization across the world, different countries, different forums. So this is an open book for anybody who wants to start their research career. So moving towards the second part of the talk, I won't take much time in this. So that is uncertainty in deep learning. So the very basic idea is, see, so far all of the deep learning solutions that are available out there. Let me take classification as the example because it's very easy to explain it. So if you have a trained classifier to classify cat versus dogs, whatever be the input that you are going to give, okay, the model is trained to say either class 0 or class 1. Assume that the probability distribution from the final layer for class 0, say 0.7 and 0.3, okay? So in that case, I would say the clear distinction is that particular image or input goes to class 0. But what if the distribution is 0.55 and say 0.45? So there is no much difference. So as a human, if I am not so sure about any prediction, I will say, I don't know. I need some expert opinion. Unfortunately, the existing deep learning solutions, they don't have the freedom of saying, I don't know. I need an expert opinion. So that is where the concept of uncertainty comes in. So the uncertainty methods, they try to quantify when the models, when can we trust the model's prediction. It has a lot of applications in healthcare. So it is mostly like we are trying to train a model, and then we are trying to understand how confident or certain the model is in its prediction. If it is not so confident, we are going to flag the human expert that's going to be a doctor or a physician. So this is one of the pipeline that we developed in our lab in association with the oncology department of hospitals in Barcelona, because they wanted a human flagging system. This task is for image segmentation, lesion segmentation, especially for abdominal cancer analysis. We have worked on the liver cancer evolution, so on CT volumes. But this prototype, whatever I've shown here, is illustrated using skin lesion analysis. So the pipeline has 5 different components. So it's a kind of benchmark to see the quality. So when it comes to medical domain, one of the major difficulty is with the ground truth. It is very difficult to get a ground truth, especially for, say, segmentation task, which is very important for the localization of a lesion. So this particular study tries to understand whether we can avoid lesion at least during the test time. So if we can use the uncertainty aspect of the underlying model, using those uncertainty maps, because uncertainty maps gonna tell you where the model is confident and where the model is not confident. So to the ground level, it is something like where the model is very much similar to the ground truth, where the model is not so similar to the ground truth. But it's a kind of distribution analysis. So we tried on the test time, if we can avoid the use of ground truth, would be really nice. So for that, we used uncertainty measures. So we have a segmentation model, which is static. So we trained it only for once for the whole study. And the second module is the uncertainty quantification module. So there are a lot of methods available in the literature. Few of them are Monte Carlo dropout. So the idea is, we all know we can use dropout during training to make the model, generic, more generalized, like not overfitted. So in this idea, we can apply a percentage of dropout, which will switch on and switch off the neurons randomly during training. But Monte Carlo dropout is applying dropout during test time. So what will happen is, if you pass an image through the network and if you apply dropout during the test line and you repeat the testing for say 10 times, from a single deterministic result, we are going to generate 10 different results. So it's primarily the idea of uncertainty quantification module. We call them as UMs, is to convert a deterministic prediction to a distribution so that we can apply this probability measures on that. Another method is TTA, test time augmentation. Again, we know what is data augmentation during training, but test time augmentation is we apply augmentation during testing. So again, the idea is from a deterministic output, convert that into a distribution and then a normal assembly. So after this uncertainty quantification module, we can estimate uncertainty using different aspects like confidence map, entropy or mutual information or KL divergence. That's going to give us, uncertainty maps like this. So in this case, if you have a red region, the meaning is the model is highly uncertain. It is not so sure whether that pixel belongs to a foreground, that is a lesion, or a background. So we used in our, this is the first part of the module. And then we introduced, a multi-branch regressor. So this regressor is going to take the input image, the predicted segmentation map from the deep learning model. So again, this is one-time training. So it's not that much complex to train one segmentation model once. So after that, it's only what we need is a predicted segmentation mask. And we are also using these uncertainty maps. So as you see, when you test an image, so this regressor is going to generate the segmentation quality. Okay, so in this experiment, we used dice. If you want AUC or any other matrices, you can replace that. So when you see during test time, you don't need the ground truth because this is one time, the segmentation model is one time trained, which is static, keep aside. And the rest of the thing you can just do only by using the predicted segmentation mask and the uncertainty mask. So the cost of generating uncertainty map is very less compared to generating ground truth, which need a lot of manual, intervention. And we also experimented on this aggregate uncertainty score because we have different uncertainty estimates. And because we want to know rather than just giving these kind of heat maps, if I can give one particular value between 0 to 1. So if the value is more towards 1, the model is very uncertain with respect to that particular case. If the value is towards 0, the model is kind of confident in that case. So we can just filter out these outputs based on the uncertainty aggregate score. And then we can use these outcomes to flag the doctors or sonographers to redo the scan or reanalyze the whole CT volume. And in this particular work, we tried can we use any other lesion-specific features to reduce the uncertainty of a model, or improvise the confidence within a model with respect to segmentation as a task. So the idea is this is a unit architecture, which is a well-known architecture for medical image segmentation. So in this architecture, the generic unit architecture takes input and the ground truth and generate the segmentation map. So what we tried was the lesion specific, any features that explains the lesion. So what is the area of the lesion, or the boundary details of the lesion. So this is a kind of the initial pilot study we used a structured data. But if we have access to a medical report that actually comes from the doctors, you can replace that also here. So this data that is very specific to the lesion is being combined with the bottleneck is a latent space of the unit. So in the encoder learned from the image, in the latent space, we also combined this lesion specific features so that we want to learn the whole model from the very specific lesion details as well, but the task is segmentation. And we analyze the whole model's uncertainty in terms of uncertainty modeling. I explained earlier, Monte Carlo dropout, test time augmentation and assembling with different combination of uncertainty estimates like confidence map, mutual information, entropy. And what we found was the proposed model, we call it as meta unit. The uncertainty was very less, which means the model was more confident because it is also getting an extra information and additional information, which is very specific to, lesions. So that's all for today. Now I am open for questions.
Ma'am, hello, good evening. This is Saili Salkade from Mumbai, and I'm doing my research in the TB detection and using the deep learning and explainable AI techniques. So, is there any? Can you guide me regarding some of the key points from research point? Means how I can these models, they GradCam plus or ScoreCam, yeah, Line, and all these models are existing. So if I want to do some real research work in this explainable AI, so what points, means what things can I do regarding that?
Okay, so let me clarify one thing. So are you trying to develop a new explainable method, or what you're looking for as a part of your research? Because I explained a few methods like that we developed our own explainable XAI algorithms or models, which is motivated from methods like what to say, GradCam or GradCam plus plus. So in your research, are you going to decode your model and understand what is going to happen? Or do you really want to develop a new explainable AI method? So you can actually go in these two directions, but coming up with a self-explainable method may take some time. That's what my personal experience. But if you are using the existing methods and coming up with some hybrid methods and then using that to improvise your model or to make your model more robust, that will be, easy to go.
Ma'am, actually what I have done is I have applied all these techniques, GradCam plus plus, then ScoreCam, Line, and I tried to see the results. So for ScoreCam, I could get some proper heat map, and GradCam and all these things. The heat map means sometimes what happen, it is basically chest X-ray. So it is not showing the proper regions, location of the disease. The heat map is going somewhere else, means it is delocalizing, or it is not capturing that region properly. So this was the observation while using different techniques, and I tried to use the Shapely also, and find out which features were contributing towards my research. Means for the TB detection, like age, weight, you can say, or the drugs which were used. So in that direction, can you guide if I have the existing techniques with me? And how can I improvise them or use them from research point?
Yeah, if you have, I mean, if you tried all of these existing techniques, so this is what I was explaining. These methods are purely subjective. It may be different from task to task and data set to data set. So my suggestion would be, if you have access to any clinical data, say for example, for patient specific clinical data, you can combine that clinical data along with this explanation methods, whatever you tried, which will help these explanation models to go more localized and give you more relevant explanations, I would say. So at least that's what we observed in our research.
Okay, so that meta unit model you just now you showed, that can be
Yeah,
used in my case. You can provide some help regarding that model.
Yeah. I think the meta model, whatever I explained, we tried it on uncertainty, but the same method, the same idea can be, you can use it in explainable AI methods also. The paper, I think it's online in my profile, and if you need any help, I'm happy to help you there.
Okay, I will mail you personally, ma'am, whatever is my requirement according to that.
Sure.
Yeah, thank you so much. Very nice session, ma'am. Really enjoyed.
Thank you.
Madam, this is Shivadasan from Vidya Engineering College, Thrissur, Kerala.
Okay.
Yeah, I also my MTech from Amartya Vishwavidyapitham from the same Sen.
Okay. I am basically from Kerala.
Oh, I see. Actually, I could not get your email ID. Something was shown, but I could not note down. So could you please give me that email ID once again?
Yeah, I think I can put it in the chat.
Okay, that will be great. And in which year you did there, MTech?
I did from Sen, I think 2013 pass out.
Oh, I see. Okay. Thank you.
Yeah, I put it in the chat.
Any other queries, please?
Actually, ma'am, one more question came to my mind, that is there any upcoming explainable AI technique, because this has been used for a longer period, right? Means grad can this. So is it something?
Yeah, there are a lot of other variants of grad cam. People call it like score cam. I mean, so many different variants, I would say. But if you ask me what is the latest version of cam or grad cam, I don't know. Maybe Google Scholar will help.
So it might vary, no, according to the type of data or like that. Some might give, some technique might give work better for that data set, or some like that. It will change from data to data.
It will change, but I would say to come up with if you are observing, if the change is too much, I would suggest to come up with the hybrid approach, so that you will have the advantage of all the methods, I would say.
Okay, ma'am. I have tried something regarding multimodal AI also, ma'am. So what I took is the gene export and this chest X-ray information, and I fused together. But as compared to the chest X-ray or images, it was the results improved tremendously when I fused both of them, textual and image data. So that part, that output, I can use as your meta unit, like just you now showed me, no, in the same format.
In the meta unit architecture, because that was a pilot study that we did in our lab. So the metadata of the lesion was structured in nature. So to convert that into the shape of the latent vector of the unit, we just used a simple embedding layer. But if you have access to, say, medical report, you can replace that with any kind of, maybe any language-based models or embeddings, which can extract more patterns out of the medical data, and you can provide them. Or any GenAI methods can also be used, because I've seen few papers where people use this kind of medical report and then convert that into a low dimensional representation and then use that further to improvise any other architecture or any other task. I think that would be a good idea to explore.
Okay, ma'am. Thank you so much. I will just mail you, and please share me the paper or some help if I require regarding that.
Sure. Whatever I
Okay,
can.
thank you once again.
Abhishek,
Respected Dr. Sikha,
Hello.
on behalf of the organizing committee, I extend my heartfelt gratitude to you for delivering such an insightful and enriching session today. Your expertise and expandable AI, uncertainty in deep learning, and computer vision application has truly burdened our perspective and provided valuable knowledge to all of us. Once again, thank you, Dr. Sikha, for sharing your expertise with us.
Okay. Thank you for inviting me. I hope I was able to explain few things, whatever I'm doing here. So thanks once again.
Thank you.
Thank you. So, Dr. Prabira, I can leave right now, right?
yes, for sure.
Thank
Okay.
you. Thank you. Yeah.
So the next session is by Dr. Devabrata Samanta. Just please wait for the 5 minutes. Please. Sir, shall we start? So I welcome you all to the second session of today. And in this session, Professor Devabrata Samanta is our research person. So I would like to say, Abhishek, kindly give the brief introduction of Professor Samanta.
Sir. Good evening, everyone. It's given me immense pleasure to extend a very warm welcome to our distinguished speaker, Dr. Samanta, Program Head and Assistant Professor at the Department of Computing and Information Technologies at RIT Kosovo, Rochester Institute of Technology, RIT Global Campus, Europe. Dr. Samanta is an accomplished academician and researcher with a PhD in Computer Science and Engineering from the National Institute of Technology, Durgapur, India. Specializing in SAR image processing, he had made significant contribution in diverse areas, including image analysis, video surveillance, deep learning, blockchain, satellite, statistical modeling, wireless ad hoc networks, and neural language processing. He had completed multiple consultancy projects, guided PhD scholar, and secured international research funding. With an outstanding record of over 260 publications, 22 patents, 13 authorized books, 22 co-edited books, and several best papers. Dr. Samanta is a globally recognized academician. He has also been associated with reputed publishers such as Springer, Wiley, CRC, and Elsevier as an editor and reviewer. Beyond research, Dr. Samanta has actively contributed to the academic community as a convener, keynote speaker, session chair, advisory board member, and technical program committee member in numerous prestigious conferences. We are truly honored to have such an esteemed personality with us today, and we look forward gaining valuable insights from his expertise and experience. On behalf of the organizing committee, faculty members, and participants, I extend a heartfelt welcome to Dr. Samanta. We are grateful to you for joining us and sharing your knowledge in the FDP program. The session is yours, sir. Sir, you muted your voice.
Audible, sir.
Sir, please unmute your voice.
Yes, hope am I audible now?
Yes, sir.
I think
Yes, sir.
someone is changing my control. Okay, no problem. We'll manage this. Just give me 1 minute to share everything. Yes, good evening. Good evening all. Basically my place is afternoon, noon, just like a different time zone. It's happy to be part of this prestigious UpDP and the n number of audience. I really appreciate to the organizer to gather this different kind of regions, all the participants. Basically 1.5 hours we will do some hands-on session, some real-time practical based work, because in European environment we need to be create some product than the other work. Basically most of the work we can follow up by the publication base, or we have to create some activity in the part of the different presentations. But in our environment, we have to create the product. We have to create that actual application in the field of this. So today, I will project my ongoing 4 applications in the medical sectors, where that deep learning and the machine learning, they can give slightly better activity and the output in the terms of medical sectors. Thank you, professors, to introduce myself. This is, I don't want to spend much time. Depends on that they can get all the informations previously. I am the first Indian who worked at RIT Kosovo. So Prime Minister gave me that award. Apart from that, Kosovo, North Macedonia, Austria, Germany, Finland, Brazil, and Morocco, we have some research centers. US government, they are using my algorithms in their cyber process in the medical sectors. So I received the medical badge from there. In India, IIT Kharagpur and the NIT Raulkela, I have my research collaboration in the part of different kind of deep learning process. This is my current stage is more than 7 months is snowfall. It's very difficult to manage the real-time activity in outside the campus. That is, most of the European environment, they want to continue their activity from the home, like the COVID situation. So obviously, if you want to manage, if you want to control everything, so obviously we need some algorithms who can predict a better way in the terms of long distance process. It's not the 5G, it's not the part of the remote control, but we need a strong algorithm to manage something real-time data set in the terms of everyday activity. This is my team of some of the UG students, postdoc students, and few master students and the faculty members. We are trying to solve the societal problems in Kosovo or Balkan region in this part of the European environment. And we don't have any exactly syllabus, we don't have any assignment or the exam based process. Every year the students, they have to be create one real time project, and they have to sell the company. If the company purchase the product, the students eligible to go the next level. So this is the work process. So that is the way to execute our daily life in the terms of different way. Now we come out to the topics as we focus on these medical sectors, machine learning, deep learning, and the part of the few medicine sectors, how that upcoming traditions is going on. Hope you got the news that this all over world, the Balkan region or the small country, the Albania, they first launched the AI minister. So because day by day, the all over world, the huge corruptions in introducing the part of the ministry level. So in the first on the country, they launched the minister as a AI. So that means AI sector have a huge demand day by day in the terms of different production process. Today, I'll project it only the terms of the medical sectors, and we can create the different kind of predictions that give you the uh, highest accuracy level in the terms of societal impact process. Is a common question: why you always select the deep learning? Why you want to always select the machine learning or the next level that computer science AI process? And some people, they are move on in the expandable AI process also day by day. But the question is, with some data we can create, and then we can go for the prediction model. So if you follow these basic steps, automatically we can create our daily life problem statements in European environment. As you know that 7 months snowfall, that means it's very difficult to direct heat to the sunlight to the skin. So that means the huge uh, process of the skin cancer in entire European environment. So always we tested the first algorithms, is it suitable for that cancer detections or not, skin cancer detection or not. So this is the way we can train the algorithms and go for the next level. Sometimes we execute in the terms of different kind of survival process, that how these algorithms existing process or previous medicine treatment techniques, they can support in the upcoming trends. So that also we can give a different kind of prediction model. Hope you know, in the times of the COVID, lot of different kind of training tested algorithms, medicines, process invented, and suddenly the Russia also want to be launch the first cancer vaccinations process. Is a huge revolution happen in the terms of this kind of prediction model and testing and tested process in the terms of different kind of medical sectors. Yes, we have a huge challenges. First thing is that every country they have different kind of law of medical sectors. They have different kind of sensitive data. Accessibility is the very difficult process. So what we are doing, we are creating a model in Balkan regions, European environment, but I have to be sent in India, Niman's Hospital, Bangalore, to test, to got the approval process. So it's a very complicated process, and day by day that the every country they have the law, and it's very difficult to access that permission process. Now we can move on to some example that what exactly we can be supported as a academicians, as a researchers in the impact of the society in the terms of AI for the deep learning process. As you know that when you start the deep learning or the machine learning, obviously some people they want to follow the traditional techniques, CNN, RNN, GAN process. So obviously we have to be plan for the first traditional techniques, then we can give you one by one of our input, what exactly we are updating in the terms of this traditional model to the new model process. When as a basics researchers they start from the imaging techniques, either X-ray data or CT scan data or the MRI data. So they have 10,000, 20,000 or 50,000 data maximum. So that kind of small amount of data, if you want to execute in the deep learning or AI based algorithm structures, so obviously he first selected in the terms of CNN process because it is easy to be fit for that particular techniques. And most of the Indian environment or European environment of the CT scan data set directly we can upload in the CNN model process. So this is one of the plus point for that. But day by day the algorithms need to be upgraded in the terms of the techniques, what exactly the outcomes we are getting. Like we are getting the ECG data, EEG data. So that kind of huge number of time sequence data, when we want to upload in the CNN model, we are getting the first error. The space complexity and the time complexity is a difficult process. So that terms we have to be upgrade in the terms of CNN to the RNN model. After that, day by day, few hospitals they have a single data centers. One small example, the Apple Hospital have the all over India, lots of different kind of data centers they create, and they have centralized data process. And as a researchers of Apollo environment, if you want to access any MRI data scan data, so automatically that file they will not allow to execute in any different kind of distributed system process. That means CNN or RNN default is distributed system, so they cannot allow to test it. So that cases we have to be use the different kind of environment that is provided by the GAN, so they can execute this process. So this is the way you can easily understand that how one researchers can be improved in the terms of CNN to RNN to GAN process in the different kind of environment, data accessibility, and the different kind of medical application process. Now I will come to the demo, because if you execute some experiment data, it will be very easy to add up fit for the basics environment for that terms of medical sector in the AI process. One small example, that the two inputs, and we can get that basics output if it is one in the terms of input process, so we get that positive answers. These are small kind of experiment data or model we want to create, then we can improve one by one size of the data set, then we can improve the prediction model and all the things. So if in this cases, if we use this particular basics input as a 0 0 0 1 1 1 0 1 1 1 1 process. So now we can move on in the part of this experimental process in that terms of this Google Colab and the Python platform. So this is the why it is very easy to access, because it is no need to install anything. It is free. Google Drive is available, and they can give the space to execute on the process. So if you want to create the first neural network of this small model, just we want to create the array process. First, we feed for all the array in the process one by one, like that 0 0 0 1 1 0 1 1, what exactly that we create that getting the sample process. Just we store one of the variable in the part of this input features. Before that, we have to be install one library. It is very easy to be execute the process. Then you can store all the input as inside the array. Just I print the array to get the result, that is match or not. We store the value. And what is the target? Our target is 0 and all 1. So we can create all the output the same way, target output. If I click, it is stored. So this is our that basics requirement of a model is ready. Now we want to fit for weighted value. We want to fit for the bias, sigmoid functions, and also we have to be reverse sigmoid, which is called the derivative of the sigmoid process, to be get that our prediction model fit for this small data set or not. Now we can use that bias is 0.3, then learning that obviously that 50%, 0.5, then sigmoid find functions of this input, and then we can execute that reverse of this process, derivative of the sigmoid functions. After that, we are trying to give that minimum 1000, 2000, 5000, 10,000 time execution process to fit for the training process. This is to be executing in the part of the process. So what we will do, we will just default try to 10,000 epoch times to execute this process. For the feeding, you have to be do this input weights plus bias. This is the basics logic of the all kind of that default that deep learning process. Then we have to be give that forward techniques and reverse engineering backward to calculate the error part. And we have to be check that if error is positive or negative. So then we can calculate the next level of the process. If it is negative, that means our process is getting a proper direction. If it is positive value or tends to 0, that means our model input or bias are not proper. Then we can calculate the derivative process, multiple derivative. We have to be input and the output devices process and update the weight value. And now the model is ready. We have to check one by one. If we give the input is 1 and 0, so if it is input is 1 and 0, output is 1. So now I will check that input is 1 and 0, what is the result is coming? 1 0 1 1 0 0. So all the testing process we will execute one by one. And the model value if more than 0.5, that means go up, that is called 1. If it is less than, it is called 0. So just to see 0.3, that means it is counted as a 0. 0.6 1 1 1. So output is coming 0 all 1. Now I can check output is 0 all 1. So that means what exactly we trying to create a neural network, a small data set only for the 2 input set of that 4 different kind of the combinations, and we got the output after training, after test of our weight value and the learning rate. What we predict that data giving the actual result what exactly we defined. So that means this basics model fit for next level of application. So now we can improve the number of inputs, number of size of the data set, and then we can check that next level of the applications. One of the small testing process that always we consider as a basics fever or not. It's not COVID. It's just only for that. Sometimes the different kind of virus is affected in different region. So this is the basics for tested that suddenly your nose the smell is going or not, that your weight is losses or even too high gain or not, continuously runny nose and the body pain. So this is the basics for combinations most of the doctors they prescribe. Let's check for the 7 days or the 10 days data or the 5 days data, and then you can be define that yes, you are addicted at the terms of the virus viral effect or not. It's not COVID, but some basics viral test. basically, if in European environment, if the temperature is changing midnight to early morning, so that durations maybe 1 a.m. to 5 a.m. these durations sometimes so cold and sometimes it's no snowfall. So if this is the fluctuation done. So if the people they forgot to switch on the heating systems, next day they have these four basics problems. So most of the doctor blindly they will test it these four condition. So that is we have to create one algorithms to basics kind of checking that particular persons is under any positive of the viral affection or not. Same thing, we have this 1 2 3 4 different kind of variable combinations, and we have got the one thing. So what doctor they assign that if it is any two positive, maybe your body pain is there, loss of smell is there, so we have to go to the positive. So this is the way what exactly we are getting the result, that how the people can predict under the virus affected or not. Now I can move on this sample of that prediction process, that it is working or not. Same thing, we have to input the array as what exactly we define this. It depends on the speed of the process. I have to be terminate other programs. It is easy to be execute, otherwise the machine will be slow. I close the other programs. First we have to be define the array of this particular three combinations: 0 1 1 0 0 1 1 0 0. This same thing, just copy paste 1 0 0 1, all the things. So this is the way we just give this particular combination in the process. And same way we tested bias value, sigmoid function, derivative sigmoid functions. Then we have to feed the forward and the backward process, and we have to be execute the 5,000 times to test the trading the data set. So previous programs we execute that 10,000 times. We execute 10,000 time to fit the trading, but here the number of process is slightly bigger. So that's just we are giving the 5,000 process, because sometimes you have to fit that. Don't waste your energy if you create a model and that model not fit for this particular process. So this is the one of the uh, demand in day by day when you want to launch this software in the real-time platform. Basically these small algorithms, what our students or we are doing, that we are converting the exe file, and through that government of Kosovo we have one platform. If you create one algorithms, send to them for the test, and they will forward to all the employee and all the citizenship in that particular Kosovo. They have to download and check these algorithms, they are virus affected or not. So this is the way we are tested this kind of real-time dataset process. So that means if it is more than 10,000 times, so it's the small mobile phone will be hot. It's too more energy will be required. The power consumption will be concept. So that means we don't try to go minimum 10,000. Sometimes some cases 5,000 is enough to get the results. So that is the our optimization technique process to minimize the systems. Just I want to execute that, then you can see that how it is working or not, and what our prediction model to that actual data is coming properly or not. So same thing, we have to be execute all the input process, and this is our output process. And after that we just tested few process, not all the things. 0 0 1 0. So 0 0 1 0, what they want, 0 0 1 0, last one is a 0. So check it, 0 0 1 0, it should be 0.3. That means below of the 0.5. That means 0. That means our creating the model fit for this model also. That means that same what exactly executing the neural network model, same thing can fit for this process. Now we can go for some real-time data set. In European environment, the students from class 6 or 7 or maximum class 8, they started a huge smoking. Is a very disease in entire environment in European environment, and we have a big challenge to minimize the smoking addiction process. Suddenly, last 2 years in European government, European Union, they send official email to all over the European countries that please try to check the diabetic effect in the smoking. So it's a huge relations to in the terms of smoking increasing, and parallelly the diabetic number of patients also increase. So one of my students, they create one of the data set of 37,000, because it's very difficult to cut the data also on the challenge. 37,000 data of the smoking and the diabetic patients. They have the one relations they want to fit for creating a basics neural network model. So before go for that part, we sent an official email to the government of India, Neiman's hospitals, three conditions: that smoking, obesity, and the exercise. So these three things, how it will be linked with your data set and the output measurement in the diabetic. So they approve this only three logics just to count this particular process, and obviously in the terms of more than 70 to 78% accuracy, you can got the patient is diabetic or not. Basically, in the research papers, we can see that 99%, 98% accuracy of the diabetic prediction model. But realistic, when you want to launch algorithms for the particular environment in where I am living in the Kosovo, we launched this particular process, and we got 78% accuracy. The government is very happy because we don't have any other different kind of prediction model to execute here. So only 78% accuracy, they happy, and already 4 hospitals they execute our this particular model. So just I will execute once again to move on this diabetic prediction, and we can predict 10 to the power 23 seconds. So it's very less. Below 1 seconds we can execute that environment, that family members, that how many people they can under the diabetic survival or not. So same thing, we just give the input array of these combinations of that part, that process, that three parts: smoking, obesity, exercise, and the diabetic. And same thing, 0 1 0, like all the combinations we put, and what exactly that our array of the output model that is fixed for the process. After that, we change slightly sigmoid functions bias value and in the terms of the weighted value, because this is our test state depends on the what type of data set we are executing and how we are process of day by day execution systems. And what we can see that this particular three properties is independent data set of the parameterize. So that shows no need to change the huge bias value. So these kind of features we are executing, that reasons no need to be change that 10,000 times for execution process, and we minimize the cost of the evaluations of the execution process of that on these particular algorithms. Just we test it one sample 001. So what is the required 001? If it is that process, that diabetic is the negative. So if we give 001, our model is coming less than 0.5. So that means that our sigmoid function is giving the proper result in the terms of this small model data set. So we need one positive also. Positive means we can see that 0 1 0. So just we change 0 1 0. If we execute these particular functions, it's obviously more than 0.5. That means it's considered as a 1. So this is, that means what exactly we create this particular model also they approve in these diabetic prediction techniques. So this is the way we are creating the small algorithms to fit for societal impact in the terms of collecting the data in where we are living or where exactly we are doing the practical base of work process. Now we can move on
Sir,
some.
sorry to interrupt. Can you share this file?
Yes,
Uh,
yes. Obviously, it's all the codings. I'll share to that organizer. Don't worry. You can take from there all the codes.
Okay, sir.
I will be execute another 10 20 sample example code also. Okay. Now we can move on that next level. Next level means now as if academicians, we know that when we start a small research, it will be very difficult to execute in the terms of uh, techniques or the process where we can start. So it's a common question. So as a academicians, as a students, where we can get the data set, or what type of model we can run from the steps one. So that we can start after 2 minutes. We have some hands-on activity in the terms of the process. I just request all of you, please go to this menti.com and give some code of, and one basics questions. You can see it, you can open by mobile phone or you can open by laptop, desktop, whatever, just a browser. Go to the menti.com, please give this code. One question is available. I think, hope you already experimented a lot of different kind of model in deep learning and the AI process. So which is you want, because I want to understand that audience, what exactly they need. I want to give that kind of experimental data in the terms of their request or their requirement. So please, I request you, please go to the menti.com, and I can switch on from here also, I can see it. Please go to the menti.com and you can easily uh, see the one small questions. The code is 52747459. I'll just copy this link and I can give you this particular in the chat box also. Please go to the menti.com and you can easily switch on by laptop or desktop. Please click this and give this code 52747479. One people already reply, so I need minimum 50% people or 50 people can reply the answers. I just request you, please try to reply more. Go to the menti.com, give this code. One questions will be visible, depends on your experimental requirement. Just give the answers. Oh, it's very good. 11 people response, highly appreciate. Whatever exactly you have some different kind of problem statement, different kind of process you can execute. Please visit the menti.com. We have another 2 minutes time, and depends on your request, what exactly you want in your upcoming futures experiment data, which model you want to execute. Just give this particular process, select it, and then we can move on the next hands-on session activity process. I need slightly more participant. You have another 1 or 2 minutes time. I request you, please apply more.
So please share the code, sir. Sir, please share the code.
52747479. 52747479. Please visit to the menti.com and the code is 52747479. Okay, what we can see that 49% people default their move on the CNN. Okay, it's very a very impactful research process in the terms of Asiatic environment, how the people they move on the AI start from the CNN. We'll come out some experiment data also that how we can change this mindset up to CNN to RNN to GAN process also. 20 people reply. I just need slightly more. I request you, please visit menti.com. The code is 52747479. You can see the screen. This is the visible. The code is 52747479. 22 people response. I Needed slightly some more. Out of 22, 17 people reply. It's free environment. Don't worry. There is no, your data will be accessible to the other people. You can be just give your informations. Nothing is required. Just only one questions visible that you can give this particular answer process. We can wait another 1 or 2 minutes. Then we can move on the particular session process.
Oh.
53 it's CNN. So very less number of people is using the RNN. No problem. So after that, my sessions, you can easily move on in this particular direction process. That how it will be work is more effectively result in the terms of the techniques. 21 people reply. I think we have 138 people participate. So I just request kindly reply this mentimeter.com or the menti.com. Please give the code 52747479. The code is this. I can wait another 1 minute. Then we can move on the next part. Okay. What exactly this data projected to you? That default people start from that 52 target audience. They want the CNN, 30 only GAN, and the 70 the RNN. Basically, this is the process. What exactly the environmental or that what kind of data you are available, that data, which purpose you are using. In Europe, we don't have any strict rules, but what kind of data, what kind of societal problem we are accessing, CNN we cannot use at all. So default we have to be move on tested from that RNN and then next step of the GAN. I will come out that one experiment data, that what exactly we are using uh, uh, our different kind of level of the research process. So one of that small video that how that our students and our academic team of Rochester Institute of Technology, RIT Kosovo, we have one of the contribution in the terms of these particular medical sectors. First you see the video, then I will come out that what our contribution in this particular model.
This is not a doctor's office. It's Forward, the world's first AI doctor's office. It all starts with the CarePod, an entirely new approach to healthcare with prevention at its core. With health apps, your care team has the latest technology to treat the issues of today and prevent the issues of tomorrow. We'll start by establishing a baseline of your health, diving deep into all aspects of your health, past health history, current health state, future wellness goals, body scan, biometric monitoring, blood testing, and more. It's all about understanding where you are today, where you want to be, and how to get there. After establishing a baseline of your health, you are able to personalize your care with health apps built for you, like our Heart Health app, shown to lower blood pressure in 90 days, powered by CarePod and at-home biometric monitoring. We'll be able to detect murmurs and other irregularities and help lower your risk of a heart attack or stroke. With a focus on keeping you healthy, you and your care team will be equipped to make the right decisions for your long-term health. Or our skin cancer scan app, which enables you and your care team to track things like mole growth and skin lesions over time. Or our mental health app, to monitor anxiety and depression with ongoing guidance and support. Whether it's weight management, diabetes screening, or everyday care, like a routine blood draw, COVID-19 testing, or kidney and liver health, there's something for everyone. Because health isn't just about seeing a doctor when you're sick. It's about continuous, comprehensive care that addresses your health concerns today and prevents those of tomorrow. The world's first AI doctor's office. It's forward.
Okay, so basically, in European environment, day by day, the number of doctors or number of, what I can say, that medical sector support team is very difficult to get. Is a huge demand, either nurse, either doctors, or the medical support team. So day by day, the people, they are trying to move on in AI doctor process, but it's really difficult to imagine that how it is possible to physical sectors to move on the AI sector. It's true. It's true because of how the AI can trustable in the part of the decision level sectors process. But the question is, if you don't have anything, so you have to be move on the AI process. So this is the current situation of Europe. If you go for to purchase one paracetamol, you have to be go doctor appointment, doctor test it, after that prescribe, then you have to be go and purchase to get this paracetamol. So this is the 4 steps in European environment. It's not easy matter to get a paracetamol also. But in India is different structure. So these 4 steps, now the people of European environment, they want one support team to get the basics needs of the requirement of the health sectors. Like, we have diabetic patients, we have what I can say, high pressure patient, we have some skin disease, we have some different kind of eye disease. Sometimes the most of the people, they have that vitamin D lack of most of the European environment. Is a huge demand of vitamin D lack process. So this kind of basics requirement, if you go to the doctors, it's a huge process. So now the few first world country of already Netherlands and Germany and Poland, these 3 countries, they launch this pot. It's a very interesting system. The small box is there in the center. People will go, they will pay €2 to €3 by the card. They enter the particular box or the pot. They've dress the particular quality of that sensor using the dress process. After 25 minutes, they'll got all the report in the mobile phone. And it is a huge demand that Sunday, Saturday, people are going out for the family, and they have some 20 minutes to check the particular pot process, and they got the report. So this is the way they are people creating this care pot. And this my country now, current Kosovo, we have a different kind of pot. I'll be demonstrate that part also. And this kind of sectors that our students, they creating the small algorithms depends on that particular data set. We launch in Poland. So Poland data set only we can use to test it the experiment process. And the Poland government, they allow us to use our algorithm for that particular pod process. It's easy to access, easy to be install our algorithm this kind of environment because it is available. So as our students, these particular sectors, one is that blood pressure control, and this if the people age is more than 35, suddenly they have the eye problems. So that kind of testing process, and the basic taste of tongue, because suddenly if European environment, people have one very common disease, they don't have taste of the food. So if it is too spicy, less spicy, or it is sour or the sweet, sometimes suddenly the man have no taste. That means they have some viral effect. So this kind of also it's a common disease in this in European environment process. So this kind of tested you can easily get within €2 to €3. You can spend and immediate report within half an hour got in your mobile phone. Another project is, it's also very interesting. It's near to the Germany. border in the process of the Poland, small city. One of the health sectors insurance company, they gave the project. Basically, in European environment, without health insurance, you cannot survive. You cannot live also. Every people, they have to be health insurance. Otherwise, they're not allowed to enter that particular country process. The problem statements that maximum old age people are in Poland, and the old age people are frequently sick and fever. And if you go to the hospital, treatment, come back, everything is under the insurance company, and it's too much increasing the bill. So they put the open problem statement, and lot of company, lot of team, they visited that particular area. And me and our team also, we went with our students. What we observe, these particular cities, the city name is Ostrova. Every building a smart house, because they are in that level, that everything controlled by the mobile phone or the IoT device. Either it is washing machine, it is the refrigerators, open the door, close the door, open the garage, everything. And because the family members are living in the big city, and they want to observe their old age people in that particular smart house, easy to manage, easy to observations. So this is every device under the part of this particular process. Then what we observe with our team, we stay there 17 to 18 days. That every house, they have different kind of IoT device, but the hacker, they control the air condition data in the midnight, 11 a.m., 11 p.m. to 3 a.m. or 4 a.m. This particular data pattern we observe, and that automatically the air condition data is in minimize, because all the IoT device are in stored in the cloud. So cloud data, anyone can hack, is very easiest way. It's not that the toughest problem. And they are minimizing the air condition data. So the old age people, they don't have a time or energy to check the air condition temperature in the midnight. They are sleepy mode, and next day morning, due to the temperature minimize, they are sick and they have to call the ambulance. So this is the different kind of problem statement is coming. That how deep learning solve this? Yes, we extract the data pattern, that what exactly the particular process of different kind of IoT device data we extract. What we observe, the data are the same kind of changing the particular time. That prediction analysis, and we convert the automation system to the manual. We remove all the IoT device of the air condition process, which can more affect the temperature techniques. We remove all that automatic systems, IoT device, we change it is manually. We fixed a persons who can control entire house manually, not at all the automation process. And from this process, we converted, and that next 3 to 4 months, we observe that yes, that old age people of that particular society is less number of sick going on. And couple of months, we are receiving the good impact of the process from that old age people. They are so happy, and they are sending us the appreciation letters. And now our project is that another 2 years continuation process to observations of that medical sector data of what exactly they are using. So don't think that your data or AI or deep learning can support exactly the medical instrument process. Sometimes the environmental data also can support a bigger way in the medical sector. So this is the one of the project what exactly we experimented a different way, and we converted the different technique process. Now, how we can convert in these challenges in the terms of theoretical concept? Obviously, the first process is the data considerations. Is the data set is from the rare disease? No, because this data is coming from the air conditioned data. And now we have the first questions: this data, it is clean data or not? How you can prepare this data fit for your machine learning or deep learning algorithm process? So we have two stages. One is that data set challenges, next data preparation steps. If data is clean or noisy, we have to remove that process. After that, we have to use the standardized normalization technique for scaling all the numerical features in a normal platform. So this is the another advantage of all medical sector research. You can use default. Second thing is that now the techniques or what kind of advanced process of the normalizations can be done by non-medical sector data to medical sector data. Three things is there just to check your F1 score. If it is too much high, obviously your data have lot of noisy data or unclean data set you have. If F1 score is minimized, tends to 1, like that correlation coefficient process, it will be going to be 1. And another two thing is there, that balance sensitivity specificity of the upper limit and the lower limit. You have to be check the ROC, AUC, and that precision recall curve process. So this is, I'll come some experiment, some coding I'll showcase you, that you can easily understand that how data set to be minimized these three normalization technique to access the non-medical sector data in the terms of medical sector process. Very simple thing, just you have to be define some structured data set first. What I told you previously, that you start from the small data set, then you increase the number of data sets slowly. Similarly, first we can start a structured data set that is fully clean, that one prediction model of the hospitals we can split in 3 different level: patients level, visit level, event level. It's very interesting structures. Every hospital of European, they are following. One patient came to the hospitals, they gave their informations, name, address, phone number. Automatically, the hospitals and the government, they have the centralized systems. They automatically check this patient visit which hospital before or not. That means if a patient visits same disease before any hospital, that data, new hospitals, they can easily access. So this is plus point of this European environment process. And second thing, what type of diagnosis they did previously and what current stage is required for the diagnosis. So these 3 process, current situations, we can predict and procedure by the AI environment process. So this way, the European medical sectors, most of the hospitals, they are following, because we don't have that much number of doctors, that much number of patients. So we have to dependency in the terms of AI process. Now I come out some deeply in the terms of 3 different categories. Either you go for the CNN or RNN or the GAN process. Obviously, it's the very basic things. Every CNN have that convolutions layer, ReLU, pooling layer, dense layer, and dropout. This is the major factors of you can execute all the process of CNN techniques. Now the question is, how much size you have to be start for the filter, either 3x3, either 5x5. If it is huge data set you have, either 15 lakhs, 30 lakhs of the data set you have, don't waste your time, directly go for the 5x5 filter size. If you have very less number of data sets, below 10,000, go for 3x3. So this is the way you can train your convolution layer. Second part is that sometimes you have to be restricted few filter in the terms of linear unit process. So this is the one of the addition techniques you have to be used in the terms of convolution layer, which purpose your pooling layer cannot fit for your algorithms. That case is what you will do, just change your maximum value 0.5 to 0.7. We don't know why, but when we change this value, automatically we got the good result. Basically we tested, depends on the which data set, the maximum pooling layer or maximum pooling value, how much we can change. We can change 0.5, 0.1, 0.5, 0.2, like that. We increase 1 by 1 and we check 0.5 to 0.7 is the maximum value we can get it. And finally, the dropout. So if you follow these basic steps, automatically your CNN model can give a better result in the terms of imaging. That means you have the cancer cell data image or MRI scan data image. So these 2 things you can easily get it. The 2 part, as I told, that European environment have that skin disease more, skin cancers more, because we don't have the vitamin D directly sunlight to the skin. So always we tested these kind of cases, the age texture on the patterns. So three major factors default CNN can support. So automatically that as a students or researchers, they can directly move on the skin disease techniques in the CNN model process. This is the one of that sample code. Obviously, I will execute in the terms of heart disease predictions. First, I execute, then I can come out. The experiment is very easy, and basically one of the real-time data we collect a couple of year from 2017 to 2021. These durations we collect a couple of that real-time data set is not that any agency or any government sector they visit the people and they collect. No, we have exactly the few doctors who have real-time patients and they happily collaborate with our research, and we got this particular data set. And we have a couple of very strong clean 1026 patients. That is the different kind of age, different kind of level of the heart disease. So what just we have to be execute in the terms of prediction process. So Google Colab, obviously they cannot save your data set. First you have to be upload data set. Just to click the left side and you can have the option for the upload. Just to click these symbols and you have that particular folder and you can upload this data. It's take 1 or 2 minutes time, depends on the internet speed. Just you copy the path because I have to be, otherwise it will be error. So I just change the path, so it is very easy. Control V, delete. Yes. So same thing. We have to create one standardized algorithm process. We not tell that CNN, GNN or RNN process. That is default. We will do later. Depends on the problem statements. Just I want to fit for these particular basics algorithms that how it will be work. Just I call this data set first, and it's a huge number of 1025 rows are there. And first we check that what kind of header, that means are available, and it is clean data set or not. If it is not clean data set, you have to be check that particular process. Then we have to be install the keras. So this is the one of the features we need, because sometimes the all kind of Python package default they access all kind of model. So this is our advantage. That's just I always install this. Sometimes you don't like, so you don't want, but I love this particular platform to execute this kind of things. Default they can support the functions. Otherwise we have to be design the functions process. And I define the model of default 80% 20% tested training, but I converted that 74 and 26. So that is our strongly upgrade model what we use. And we check the different kind of parameters that our model can predict the disease or not. And we also tested the confusion matrix, that if it is diagonal is one is coming or not. So this kind of tested we did, we already checked it, and all the cases we got that very effective result. And I told the F1 score is it is 1, that means you are the standardized norms of that. So but this model we've launched in Kosovo government medical sectors, and currently we have this is very small country, so we have only 28 patients now under observations of this particular model. What X-ray doctor prescribe, and the AI doctor they can give that prescriptions from their current stage. So hope upcoming we can get that more accuracy, more number of patients, so then our training data set will be increased, and we can easily get that highest get of the result process. So this is also that part of the CNN model. that four categories that obviously we converted first that convolutional 2D layer, then max pooling. After that, we use that 1D vector sector for the dense layer. Then we convert the dense layer, drop layer, and finally we got the output. So these are the four categories split in this normal CNN of the heart disease prediction model. And we got slightly good result of 82% accuracy, and expected that within 2 to 3 years we will get that more number of patients in the Kosovo environment, and then we can move on that real-time implementations in that more than accuracy in the part of this prediction model process. So what is the advantage? CNN obviously, as you saw that you can see in the here that once again that see 53 people are in the part of the CNN. So obviously that they have some advantage, they have easy to access, so that's when they are using this particular process. But in the technical terms, that if you have imaging type of the research process, it's you can say that without manual engineering, that means some machines they generate the medical sector report like X-ray and CT scan is the best to fit for your CNN model in their platform. Basically, I know that in the Asiatic environment, it's not easy to install your algorithms to particular hospitals. They will not approve you at all, and they will not allow you to test it your algorithms directly in their hardware device. But in European environment, we have options in our research lab. Our college, they are providing to creating the big infrastructures in the terms of testing the hardware devices with the software process. Just we send our algorithms, we have a team, they are installing, and directly they will test it in the hospital. So before got the approval of the government sectors, they can test 2-3 times. If it is effective result coming, then they will apply for the approval. So this is the way we are working. It's not good way to be tested, but we don't have any other options. Directly we are saying that it's the only solution to be tested our algo in the directly hardware and devices process. One scalability options also is required, and it is the important part of that. CNN default, you can use small and the large data set. So other algorithms, they can get that F1 score changing 10:1, not 1 will come if it is a small data set, or that not clean data set will be available. So that scalability is CNN is the plus point. So that's always we are telling our students that default you try to move on in the terms of CNN process. Next, one experimental project, what exactly we are doing is very interesting. As you know that the women or the girls, they loves to wear the pencil heel in European environment. Default 99% working women, they are wearing the pencil heel morning 8 a.m. to 10 p.m. So it's a common, depends on their style, depends on their requirement, societal impact, leave it that part. But the question is, if you wear the pencil heel this much continuous 3 to 4 years, 5 years, you have the very difficult orthopedic problems. So you cannot walk normally. You can see the right side corner, the women have some orthopedic problems, and if you are walk normally, left side one cartoons is moving on. So this is the way it will be work. So what exactly our project is, European environment, every city they have a center, and the mayor of my current company, my current country, they put a camera in the center. If the woman or girl not walking properly, they mark as a red color, and if you are walking normally, they put as a blue color. If you are not walking normally, they send the SMS, maybe you need orthopedic help. So mayor send this message, because we have everything data process of your face detections to data phone number. It's very easy to extract, because less number of people, the government have observed everything, government follow every records, so they know that where you are moving. So it's not that much difficult job to send a one SMS. after the phase detections. So what this project did is, the Mayor launched the camera in the center, detect the red color and send the message, you need the orthopedic support if you are walking abnormal. And the Mayor win the match in last elections because of this project. So what we did that, we create a data set how girls can walk with the 8 different points, and from that particular points we converted a normal GNN model, because it's so fast we need to be execute, otherwise very difficult to process. Within 3 to 4 seconds they need to be send the SMS, so that's why we use GNN model. And we tell that particular patient is not properly walking, so you need to be send a SMS that maybe he need or she needs that support. So this is the project, and how we can convert that techniques. That first we converted the PyTorch CNN. So it's slightly modification part what we did inside the GNN process. Obviously that rectified linear unit, we change different kind of layer process. Just to see here in the diagrams, input, convolution layer, pooling, and the fully connected. So this is our modification part, the normal CNN to this different kind of vertical convolution data of that one people when they're walking, the 8 points data we store, and we run minimum 30 to 55,000 times epoch. This is the numbers to get the solutions of train that particular city data. So this is the way we are converting the modification of CNN of this particular project process. After we success of this particular project, the government they increase our funding, and we now converted a device. So this is the one of the very interesting project. Last couple of year, me and our team, they're working closely on these particular things, and it's very difficult to get the approval to launch this product. But soon we will launch in India first, in Bangalore and Chennai. We will launch these 2 products. First, to see this small video, then we will explain that what exactly that our contribution in the research, the terms of this, and how we can be benefited in the Asiatic environment. People can be fit for this tested process.
When you come to an Eco Health Center, the first thing that happens is that you get checked in by one of our operators. Throughout the entire scan, you'll be together with the operator, who's a trained medical professional, and you'll also meet a doctor who will review and discuss the results with you. And the scanning starts with a standing up scan. We take high resolution photographs of every inch of your body. This allows us to create a reference image of your whole body. So the entire scan takes about 20 seconds. At the end of the 20 seconds, we have every inch of the outside of your body. We have your entire shape of your body mapped out, together with a temperature profile of your entire body. The second part of the scan is you go over and you lay down on a bed. There we do a cardiovascular assessment, where we measure how your heart is beating and pumping blood, and how that blood is moving through your entire arterial tree. We measure the pulse at 7 different locations throughout your body to understand its shape. And this enables us to do a much better characterization of the health of not just your heart, but your entire arterial tree. Then we check your microcirculation. These are the smallest blood vessels in your body, and we assess their capacity to supply your cells with what they need. It is believed that issues with these vessels are a common starting point for disease development. So after that part of the scan, we take a simple blood draw, where we check for essential blood tests that we process on site. The second part of the visit is going into the debrief room with the doctor. You spend about 10 minutes in the scanning room, and when you meet the doctor, all of your results are already fully computed, calculated, including the essential blood tests that were done. So the entire session is just for you to talk with the doctor, to go through all of the results. And we do it in a very different way from a traditional doctor's office, where there's no desk, there's no keyboard, there's just a big screen with an avatar of you, with all of your health information mapped onto this avatar, and a doctor to walk you through every step of how to interpret that data.
Okay, so basically previous project is fully AI doctors, because we don't have any kind of infrastructures in the Europe. So that just we fully depends on AI. But when we want to launch the product in Asiatic environment, we have some AI trust issue. It's not easy to be adopted. That's just we install two persons inside the AI device. One is that normal nurse, and one is the expertise, like medicine doctors. So then we fit for same product we are launching in India. So hopefully Indian government, they approve our process. We are in ongoing techniques. It's different team, they are working on that. So NECO, this is the first like that pot, that AI pot will launch in that Bangalore 2 and the Chennai 2. If it is approved, then we can move on, the every city will launch this one. So this is that World Bank supported this project, so it's a good impact for societal things, because day by day the number of population is so much increase in India, and that medical sector support, they need the automatic prediction process. So this is on this kind of pot, maybe some city, few people, they will get easily get the result in the terms of their healthcare process system. So this is the way we are trying to connect it with Asiatic environment to this European environment. Two different sectors, same kind of the process, and two different company they are trying to launch. So this company, our students, as it is that only this we have Kosovo data set and Kosovo societal problems. So we have only the two part. One is that dentist, dental issues, or any kind of disease in the part of dentist, and the skin. So these two part is our project involved in these particular sectors, and we are creating the different kind of accuracy prediction model process. So this is our target to be moved improvement. Hope in India we can get more number of data set, more number of patients data, then we can train it, and automatically it will be next level of prediction process. And again we come back in the European environment to launch that upgrade algorithm process. So this is our main agenda of the process technique. Now, so this particular NECO, we are not default move on that CNN. So we have to be change the slightly modification of RNN model for two process. One is that dental informations of the disease, and the skincare process. So here the three major part. One is that GRU, gated recurrent unit, LSTM, long short term memory, and that by RNN. So these three factors, we are changing different kind of parameters and prediction process in the terms of conjugation techniques process. Basically, sometimes one layer, or there is no layer at all, we use for the really when directly we connect the dropout process. But we here use minimum two layers. So this is the our advantage of getting the accuracy level. So this is the process we are trying to improve in the terms of techniques. The four different parameters which we modified, and depends on the data set, we are access of particular strict value, hidden size, epoch, seed, and the class weight. So these four, if we control properly, the RNN model is the best for this type of data set process. So this is that one of that basics requirement techniques of the RNN process. I'll come out that one demo, then we can move on that basic process. I just see that one of that standardized model, because sometimes that RNN, when we execute that, suddenly our GPU machine is collapsed because it's really required the huge number of memory shortage process. So that means we are trying to showcase you the same kind of idea inside the CNN. So this is that one of that interesting process, because sometimes if we not get the actual RNN data, RNN model, so same thing we are installing inside the CNN. So this is the one example, and same thing will be happen because of the we tested the both different process as we are executing in the terms of that Google Colab. So RNN slightly 15 to 25 to 30 minutes required to execute, so we don't want to waste that much time. Just we convert same concept in the CNN, and we use the small data set, we execute 3 to 4 seconds. So this is the reasons we design this kind of process. So basically, if you create, this is the basics model, and I'll give this code just to change your data set and the model parameter what I told in the RNN. So if you converted this process, then your entire RNN can be fit inside that model. So this is the plus point. So don't worry, I'll just first to execute this code, and I'll just explain that how the CNN data features can work. Just I stop the previous, otherwise my memory will be gone. Yes, just close. Now I can execute. Just to see is execution time 3 seconds, 4, 5, 6 seconds is required CNN. But if you want to execute same thing in RNN, if minimum 25 minutes. So just I off that part and I execute here. So what same thing, that one configuration layer, second configuration layer, third layer. So these 3 layer, basically what we did the first 2 part. So this is the conversion of RNN CNN relations between these. After that, we use that connected layer and output layer. So these 2 data, we are connected with these 2 layer. So that means this entire RNN we can execute because of the time complexity and the accuracy process of small data set in the CNN library process. And how we can accept your idea. Okay, now we just print the model. So just we just print the model, and we can see that how much output shape the parameters are used in this inside the each functions. So COVID 2D, max pooling data, conversion 2D model, dense, flattens, max, all data we printed, and we check that is exactly the same value of RNN produce, and this CNN also can produce. So this is the way we are executing the same features, same particular the RNN features in the terms of that particular technical process. So this is the way of executions that RNN can be fit a particular specific data set inside the CNN process. So this is the way we are executing this. So all the code I will provide to you, don't worry with the process. So now we have some knowledge of CNN, we have some knowledge of RNN. We have
Sir, 1 minute. Can you show the previous slide? I want to note down. Just 1 minute.
This one?
Before this. Before this.
This one?
Before this, sir. Yes. Wait, sir. 1 minute. No, next, sir. This one, sir. Wait.
This one?
Yes, sir.
Is this visible to you? Now okay? Or I can give this PPT to the organizer. They can share this PPT to all the people. Don't worry. Okay.
Yes, sir.
Okay,
Yes.
thank
You
you.
please share. Thank you.
Yes. Now you have some idea about the process of experimental data in the real-time problems. But the question is, what is the futures that which way move on in the AI researchers? As European environment have the different societal problems, and here researchers move on to solve only societal problems. We don't have that publication base or that printing base. If you observe that last couple of years, the COVID, if you search the COVID-19, I think more than 50 billions research papers available in the Asiatic environment, but how many vaccines are available in that process? So exactly that opposite in the European environment, they only want your idea how to solve societal problems. So what we observe that upcoming AI move on these two directions. One is that quantum AI and the edge AI. So one thing is that day by day, you have to be improve your in number of convolutions model, and it's so costly. It's day by day huge power consumption required, and when it is more power consumption required, it takes huge time. So these two things they want to minimize, and they one kind of research team they move on the quantum process, quantum AI. And one of the techniques process, no, we don't care about the time, we don't care about the cost, we care about the accuracy level. So they move the HAI. So if your idea of any societal problems, European environment, if you want to be move on to give some solutions, you can be approach your choice in two directions. If you want to submit some proposal, research collaboration, research proposals, funding is the European environment of the huge funding opportunities. So if your idea move on these two kind of approaches, obviously your idea will be easily acceptable process. Before close the sessions or before go to the discussion for last 10 minutes, 20 minutes, one small example. I met Mozilla Firefox director. I think a lot of people they are using the Mozilla Firefox. So in the Docotech is the one of the biggest platform in the European environment, and I met with her in that particular conference. And next year I'm in the stage in my convolutional research process. So she told that she create the entire Mozilla Firefox AI concept from the Indian Holy Book. So when I was in India, really I don't know that Indian culture, Indian inspiration is so much demand in European environment. But after coming here, I really surprised at how the people blindly follow the lots of Indian techniques, Indian spiritual algorithms in the terms of different kind of holy books. So it's very easy to impact, because always when me and my team we are trying to create some algorithms, we always compare the Indian prospective Indian data set, Indian disease, Indian different kind of doctors recommendations, then we are trying to launch here. So obviously it's a huge impact, research impact we can get from the Indian environment. So it's very easy to open your eye to your own cultures, and easily you can get the new kind of AI sectors solutions in the medical process. Thank you the organizing team to giving me the platform to showcase my research, all the things. We can come out some discussions in coming 10 minutes, depends on your questions or in the terms of chat box queries.
Yes, sir. Sir,
I can stop sharing. Yes.
I have a doubt that in CNN, whether every convolution process is to be followed by the max pooling, or max pooling can be skipped.
We are avoiding both. Okay, so we don't want to use at all in the max pooling process till now, because here data set is fully non-correlated, so independent data set. So if the data set is fully independent, so we don't want to go directly the max pooling process. So that part we trying to avoid default to go for the CNN techniques.
And sir, why the filters are of size 3x3 or 5x5? Why not any other numbers like 2x2?
Okay. So basically, if you start from one point, so that point nearby odd value is 3, 5, 7, 9. If you increase the more 5 cross more than 7 cross 7, it will be huge time complexity, because left to right or right to left convocation way they can check all the data set. So 3 cross 3 is the small box to check entire data, not to missing the edge part also. Clear my point? So if it is 7 cross 7 or 9 cross 9, so that means you have to be change the edge side 336 layer we are missing. So that kind of non-missing data set, if you want to convert, so start the small size of the convocation layer 3 cross 3 or 5 cross 5. If it is more, you have to be delete or ignore the edge part of your data set.
Sir?
Yes.
Yes.
We can go for padding, na?
Padding is how much accuracy? 50%, 60%. Okay, so there is no algorithm available in the padding is that more than 80% accuracy.
Okay, thank you. Sir,
So this is the also one of the huge research scope. If you have tried to create a unique padding algorithms which can give them more than 50% accuracy, it will be very good, perfect.
Sir, good evening, sir. Actually, I have doing a work on hardware security purpose. So,
Okay.
for how we can interpret into the AI or machine learning, sir?
No, basically AI agent is different. AI agent means you are predefined some algorithms and the instructions given they are follow. So security every time day by day they are upgrading. So AI agent cannot support that part. So my solution in the security sector in the AI, that you have to be try to minimize the number of hardware connectivity. Very simple thing. I am talking with the laptop. So that means only this laptop can be accessed or hacked by you, but we cannot access by the mobile phone, because this is my without internet now it is available. So that means it is only solutions if you have disconnectivity of the hardware devices with the single network. If you have the multiple different network, it's very difficult to hack, very difficult to access of AI protected process. You have 4 device, try to connect the 4 different internet process, so it's impossible to hack.
Thank you, sir.
Sir,
Good question. Yes, ma'am.
sir, we are having suppose 227 by 227 image with 3 channels, and we applying mask 3 by 3 mask, and that is of 96 mask filters, we can say. So how that communication will happen?
Okay,
How this
so
will be applied?
if you want to do the only communication part, you just forgot how many masks you have. Maybe sometimes you have more than 100, more than 50. It's different. Just to think that you have the only 10 mask. So
Okay.
that communications is very easiest way to create the LSTM, long short-term memory techniques, to save each mask centralized value. And if the centralized value is odd, create one algorithm. If centralized value is even, create another algorithm. So just if else. So this way they can connect and give the single solutions.
Okay, sir. Thank you.
Very good question, ma'am. Thank you. Any other queries?
Sir, can you suggest any deep learning techniques which are used for research point? Because all these models, retrained model or even CNN, RM, they are existing. But if you want to make some improvements in them or develop our own model, then what can be there for? What can be done in that sense?
No, basically, if you want to start your own research, you can start from these 3 basic things: CNN, RN, and GAN. After that, you try to update the parameter first. Next level, try to update the layer. Next level, try to update the each output recall value. So these 4 things, if you create automatically it is a new algorithms. Basically, when you want to create a normal code, but that code, if you want to install in the hardware, is a huge difference result. Clear my point? So that is just always try to check that what type of hardware compatibility you have, and that module or that parameters you try to update. So this is the only solutions. Otherwise, you cannot get the actual result with respect to your mathematical implement in the algorithms. It's a huge difference happen.
What is
Yes, sir.
differential CNN? Differential CNN.
No, differential CNN basically it's you can say that uh, regressions analysis without correlations. So this is that, because sometimes you have the huge number of data set, you cannot calculate the correlations, you dependency on the regression analysis. So that kind of cases that you cannot execute the CNN, you have to be execute that kind of CNN. Basically, if you see that big data set, that left side diagonal value all are odd, most of the values is odd. So this is the easiest way to you can check that which data set you can use the normal CNN or the classical CNN.
Hello, sir. What is the use of that reverse sigmoid function used in the first program?
You just one common thing. You have three values. So obviously the middle value we can compare is the median. Okay. Now just to increase the number of slot, 3, 5, 7 until 1000, 10,000. So it's very difficult to put the middle part in the median value. So that cases we have to be use the different kind of sigmoid functions to predict the bias or weighted this difference. So these cases we have to use this particular process. The calculate the value bias minus weight value.
Thank you, sir.
Yes. One
Can you share
question
your
came in
email
the
ID?
chat box. In
Email ID?
India, we face the problem of getting patients real-time data. Any help for this? Okay, Kavita ma'am, it's true. Basically, for that you have to be need good connection in the doctors or good connection in the data center people. So if you have some student or some colleagues, they are working in the data center of that particular hospitals, they can give you the real-time data set. So I create with the 5 years relation connections collaboration. So now they trust me and they can give me for this kind of real-time patients data of Indian perspectives. Yes, ma'am.
Sir, please share your email ID.
Okay, I will just give my informations, no problem. I just give all the data, all the PPT to the organizer, and they can share to the all the audience. Anytime if you need some kind of coding or any kind of experimental process, obviously I happy to help you. So thank you for these collaborations and interesting questions in the terms of.
So your voice is muted.
Stop sharing. Yes, am I audible now?
Yes, sir.
Yes. So basically, whenever you want to, because every day by day we have a team who are working process or execution techniques. So just follow my LinkedIn, and there lot of latest research process will be available there. I just put in the chat box. You can go through there, and in the terms of the email ID, the queries, you can feel free to discuss with me. Depends on your interest. I just submit my email ID also there in the chat box. You can find out from there. Okay. Thank you for the audience. I really
Any other
appreciate that
queries?
organizer, that Otol and Otol FDP, and there is more than 150 participants. It's very good. It's a very good connectivity in the terms of that accessibility. Thank you all. We'll
Any
keep
other
in touch
queries?
with that kind of things. You can feel free to discuss with me.
Any other queries? Okay. Sir, on behalf of the organizing committee, I, Abhishek Mishra, would like to extend our deepest gratitude to Dr. Samantha for sharing his valuable knowledge and insights with us today. Your session on indirect disciplinary research, deep learning, blockchain, and image processing was both enlightening and inspiring. The depth of your experience and the breadth of your work have undoubtedly broadened our understanding and provide us with a new perspective on current trends and research and development. We are truly fortunate to have had the opportunity to learn from some with such a remarkable academic and professional background. Your contribution to the field of computer science and engineering are commendable, and we are grateful for the time and effort you dedicated to this season. We would also like to thank all the participants for their active involvement and engagement through the session. Once again, thank you, Dr. Samant, for the presence and for making this FDP session enriching and experience for all of us. Thank you, sir.
Thank you all. Bye. Good night.
Good night, sir.